Assalamu alaikum and greetings everyone. My name is Tamjidur Rahman, metric number 60068. My supervisor is Associate Professor Dr. Abu Saleh Ahmed. My topic is influence of butanol as additive for diesel Karanja biodiesel blend. Here are the contents of my presentation. Introduction, problem statement, objective, from literature, methodology, results, expected influence of butanol, discussion, conclusion, and question answer. Here is the introduction. Fossil fuel is the primary source of energy with very high demand and popularity, but it has a higher risk of extinction, and thus many groups are working very hard to find an alternative source of energy. Biodiesel or methyl esters of fatty acid is a renewable source of energy that is produced from a process called transesterification, which is done in the presence of a catalyst by the mixing of vegetable oil with alcohol. Diesel and biodiesel have very similar properties, and the engine performance with the use of biodiesel is also very noteworthy. Here are the problem statements. The non-renewable sources of energy are depleting at a very higher rate, whereas the demand for the fossil fuel is increasing very acutely, and as a result we can see that the price of fossil fuel is getting higher every day. The emission of greenhouse gases by fossil fuel can cause global warming. Compared to the conventional diesel, biodiesel gives very lower power output. The supply of huge amount of raw material to produce biodiesel is a big challenge. Here are the objectives. Number one, to produce biodiesel from crude Karanja oil using transesterification reaction. Number two, to analyze the performance of the diesel engine using Karanja biodiesel as a fuel. Number three, to produce blends of Karanja biodiesel and additive butanol. Number four, to use different blends of diesel and Karanja biodiesel and compare the performance of the diesel engine. From literature we get Karanja belongs to the family of Leguminosae. Karanja grows up to a height of 15 to 20 meters. Biodiesel are the methyl esters of fatty acids. The oil crops or seeds like mustard, soybean, palm, Karanja and Jatropha gives the highest yield of biodiesel. Biodiesel are carbon dioxide neutral. Biodiesel extensively reduces the greenhouse gases. And finally, here we have got the formula that we have used for the production of biodiesel. Well, to start with the methodology, we first look at the flowchart of the methodology where we have from the start to the titration and all the way we have the transesterification method to storage and testing of the biodiesel. Methodology. First we have done the titration to find the acid value, and we have used this formula to find the acid value, and further we have done the transesterification method to produce the biodiesel. We have used this equation here to produce the biodiesel. Moving on, next we have the engine power output. To find the engine power output, we multiply the voltage with the current divided by 1000, and then we have got the brake specific fuel consumption, BSFC. To find the BSFC, we divide the fuel flow with brake horse power, and finally we have the mechanical efficiency. Mechanical efficiency is equal to the brake horsepower divided by the indicated brake horsepower times 100%. Now the results. We have found that the FFA value is 0.684%, which is less than 1%. Thus we continue with one step transesterification method to produce the biodiesel. Later we have the effect of the ratio of catalyst to oil. We have seen that 1% concentration of the catalyst gives the highest yield of the biodiesel, and the effect of methanol to oil ratio, here we have got 9:1 methanol to oil ratio gives the highest yield of biodiesel. So moving on with the results, or I should say expected results, we have the FTIR for both diesel and biodiesel. The infrared spectrum for both the fuel are identical, and the presence of oxygen functional group for Karanja biodiesel is confirmed, which gives less emissions. We can see that here we have the CO functional group and here we have the CN functional group for the Karanja biodiesel. Here CO functional group helps in the reduction of carbon monoxide and CN functional group actually helps in the production of nitrogen oxides. Next we have the density meter test where we can see that Karanja biodiesel has a density which is in between crude Karanja oil and conventional diesel. Similarly, for the flashpoint test, we can see that the flashpoint temperature of Karanja biodiesel is in between crude Karanja oil and conventional diesel. But for the calorimeter test, we can see that the calorific value of Karanja biodiesel is the least among all the three fuels that we have tested. Here again moving on, with the expected results from speed versus fuel blends, we can see that B20 produces the highest speed of the engine, and from the BSFC test we can see that B20 gives the least amount for the BSFC, which means that the least amount of fuel is consumed for B20. And again, with the BHP versus fuel blends, we can see that B20 has the highest BHP and the efficiency for B20 is 61.14%, which is the highest among all the blends that we have used for this test. This slide will help us to understand the expected influence of butanol. Here we have got a graph which shows the brake thermal efficiency versus the engine load. In this study, the red bars indicates the butanol blended biodiesel and the yellow ones are for the neat biodiesel. We can see that the brake thermal efficiency of the neat biodiesel are much higher than that of the biodiesel that have added butanol to it. The brake specific fuel consumption BSFC shows that the fuel consumption of butanol added biodiesel is much higher than that of the neat biodiesel, and this is same for all the engine loads. Further, when we look at the emission properties of butanol blended biodiesel, we can see that the carbon monoxide emission for butanol blended biodiesel is much higher than that of the neat biodiesel. But for the oxides of nitrogen, it can be seen that the emission of NOx for the neat biodiesel is much higher than that of the butanol added biodiesel, and this is the same for all the engine loads. Now moving on to the discussion part, the presence of CO functional group that we have confirmed from the FTIR test shows that the reduction of greenhouse gases is possible by the use of biodiesel, but the CN functional group helps in the production of NOx. From the results of engine speed, SFC, BHP and efficiency, it can be concluded that the B20 blend shows the best performance among all the blends prepared due to lower calorific value, lower energy content, higher latent heat of evaporation and higher ignition delay. The use of butanol as an additive has a negative effect on the engine performance and emission properties of the biodiesel. To conclude, we can say that this research has successfully investigated the potential of crude Karanja oil as a sustainable feedstock. B20 showed the best performance among all the fuel blends. Use of additive butanol reduced the engine performance of the biodiesel blends. Other than nitrogen oxide emissions, butanol increased all other emissions like carbon dioxide, carbon monoxide, and hydrocarbons. Okay, thank you so much. I'm looking forward to your questions.